Alright, here's a second type of projectile problem. These, I think, are a little bit easier, a little bit more manageable. These typically have something falling off a building at some speed out this way. If I say that the building's height is 40 meters high, and I say I throw it out at 10 meters per second. The biggest condition here is figuring out time. What's cool about these is that's just one time. It's not a time up and down. It's just down. It's falling. That's the most important thing to find. So how can I find time when I have a constant acceleration of gravity at 9.8 and I'm using the height of 40? I can use the equation v square, I can use the equation x is equal to VIT, which I can toss out the window really quick, plus 1/2 gravity time. I can get rid of that because I know that my initial velocity down is 0 because it's doing it from rest. So it leaves me with a nice clean distance is equal to 1/2 gt squared. Sorry about that. Rearrange it to get t by itself. It's going to be 2x divided by g. Square root the whole thing gives me t. So if something drops from 40 meters, oh goodness, let me do that again, times 40 by second function square root, second function answer. It's going to fall for 2.85 seconds. So falling for 2.85 seconds, this is the easy part now. I could throw it at 100 meters per second, 1,000 meters per second. I could throw it at 1 meter per second. I know whatever speed I give it to the x, solely determined on how long it's going to drop, will tell us out here. Well, range is simply the total time in the air, and in this situation, because we're only falling in one direction, it's 2.85. And then our velocity along the x, which is 10 meters per second. So it's going to go 28.5 meters away from the base. So they'll use things like how far from the building, away from the base, any other number of words you can imagine. It's best that you get the sketch out. You know, the problem is they might give you it's a 40-meter building. That lands 28.5 meters away. What was the speed at which it was thrown out at? Well, if that's the case, you just work backwards. And so we know that distance divided by time will give me that v of x right here. Where would this time come from? Well, this time would come from, again, how long does it take to drop? So I can turn 40 into a time by using the 2x divided by g equals t when I square root the whole thing. And I don't have to worry about multiplying by 2 because it's only working in one direction. Alright.